Hello everyone and welcome to the channel. I'm Emmanuel, I'm an airline pilot, and welcome to our tutorial for the Flight Sim Studios Boeing 727. This tutorial will be done with the cargo version of the airplane, but it will mostly be applicable to the passenger version once it releases as well. We are going to fly from Edinburgh in Scotland down to Brussels, which is going to be a quick 1 hour and 20-minute flight across Europe and the English Channel. We are going to record this flight using the old school navigation and doing the flight engineer's job manually. However, you can of course go into the options and have those taken away from you, making your life easier. However, for full understanding, that's an interesting word. For full understanding of the aircraft systems, I do recommend that you at least look over what the engineer actually does in order to be able to intervene if something happens. So we're going to start with a couple of basics over here, and the first one is that little mobile phone you have down here, because this actually contains a lot of useful stuff. Like you have the automated crew manager that can do the flows of the flight engineer and of the first officer for you, and you also have some automatic monitoring stuff down here that can be pretty useful to use. In this tutorial we're going to do it all ourselves, and I will explain exactly how to do these things. However, we have this available in case you want your life to be easier. Likewise, going over the options real quick, we have our clipboard down here, and the clipboard is the 727 equivalent of an electronic flight bag. You can see in here we have our aircraft options, we have our load manager, we've got an automatic takeoff calculator, and we also have the ability to access Navigraph charts in here. So lots of useful stuff, and it is hopefully going to be expanded even more over the lifetime of the add-on. Now, for our setup today, we are going to do the following. We are going to start cold and dark over here. We do not have an auto throttle in this aircraft because you won't believe how easy it is to manually control this. And in terms of the navigational equipment, we will be using the C-Bar INS, which more or less is accurate to the time and date of the Boeing 727, but in here you can select the default GNS 530 or the PMS 50 or the TDS GTN XI units as well that you can fit into here for your navigation. In this tutorial we will focus on the INS, but if you want to use the GPS for navigation, rest assured there is a little nav GPS switch up here. Put it to GPS and then you can simply follow your GPS. Easy as that. But as that is not a challenge, we are going to skip over that part. Now, we're going to start our tutorial right here on the Preflight page, where we are going to download our SimBrief data. So enter your SimBrief ID up here, and then click on that little cloud, and you can see now it's automatically going to populate your payload and your fuel pages over here based upon your SimBrief data. Now, you can either do a real-time loading over here. For example, if I click that button, then you can see we've got the timer running here for a real-time loading of the airplane, or you can fast forward using that double button over here, and in that case the loading is finished instantly. Likewise, we're going to do the same with the fuel over here. You can either refuel it in real time, or you can just fast forward it to finish the refueling straight away. Now, as our aircraft is now loaded, we got our load summary down here, and as it is now completely loaded, we can stow the clipboard once again by clicking on the middle of the board, and then we can start our pre-flight procedures. And in terms of the pre-flight procedures, I'm basing them on the manual provided by Flight Sim Studios online on docs.flightsim-studio.com, but I will amend them because the manual provided by Flight Sim Studio is based on a layout of the aircraft that they did not actually model. So for that reason I will slightly amend them, so if the procedures you see in this video are not the same that you have in the official manual, then the reason is because the official manual doesn't represent the actual aircraft Flight Sim Studios modeled. Don't ask. Alright, so to start our pre-flight procedures, we're going to start by turning on the battery, which we can find on the top up here. So battery on, ensure our voltage is greater than 22 volts. We can see that up here, so we have 24 over here at the moment. Next up, we are going to start the APU, and we have the APU panel located on the aft wall over here. We start by doing the fire test, so you place the test switch to the top, observe the light and the audible warning. Reset the warning by holding the switch down once, and then put the switch down a second time so that your APU starter circuit is going to work again. This is important, you gotta move it down twice, otherwise the APU starter is going to be de-energized. Okay, so with the test now completed, we can go ahead and start up our APU. So we're going to start by switching the APU meter selector up here to APU, and we have that already. And the essential power selector has to be in any position other than APU. So that one can be either standby or any of those, but not in the APU position. Okay, with that done, we go back to the APU panel and we take the switch, put it to on, and then hold it to start for a couple seconds until we hear the APU starting up. As we can hear happening right now. Okay, so the APU start is in progress right now. And as soon as the APU is stabilized, we will see that the EGT stabilizes, and then we can continue with powering up our aircraft. Okay, so that's a stable APU startup here. Before powering our plane, make sure that the two pack switches located up here are in the off position, which they are right now. With this verified, we can go ahead and switch the APU generator to close, and don't be confused by the term closed. Close in terms of the generator here means that the contactors are closed, so in contact with one another, and therefore the generator works like this. Okay, once the APU generator is turned on, we are going up to the top over here to the essential power selector and switch that one over to APU. And now the airplane has power applied. After power is applied, we can go to the circuit breaker panel on the side over here, and you will find the radio master switches located over here. We are going to turn both of them on, and if you do not turn those on, nothing listed up here, so no VOR, no localizer, no glide slope is going to work. So if you ever figure that your radios do not work in the aircraft, this is the reason why. You gotta ensure to turn those two switches on. So we check that our parking brake is set, as we can see by the red light down here, and we can turn on a galley power switch located up here. We only turn on one of the two because we want to preserve a little bit of electrical power. Now before we go over anything else, let's quickly go over the light switches we have in this aircraft, because by default this is a pretty dark cockpit. Not so much in real life, but more so in Flight Simulator, because the HDR of Flight Simulator just makes the entire flight deck look pretty dark. So for the front part of the cockpit, we got all our light controls on the forward overhead panel. You can see by default pretty much everything is turned on over here, and we have to admit everything looks a lot more readable this way than it does, well, this way. For the flight engineers panel, you also have some lights located down here, and we can go ahead and turn all of those to the maximum here. So panel lights coming on, and you can see the rest is already turned on. And if you ask me, everything is readable a lot better under these conditions. So now with our airplane powered, we go ahead and do our typical pre-flight check. You will probably be familiar with those if you have flown any other highly modeled airliner in the recent times. So we start at the bottom, make sure that our hydraulic quantities are showing well, as we can see down here, 1 and 2. We are going to turn one of the system B pumps on. So hydraulic system B is located over here, and we turn on one of the two pumps. One is sufficient to pressurize the airplane and not use too much power. Then we can move up, and we are going to do the oil quantity test. We hold down the switch, and while we do that, we observe the 3 indicators going to the bottom, then we release the switch, and we observe them going back up again. Finally, we move to the top of the flight engineer's panel, and you've got the crew and passenger oxygen pressure indicators up here, and we make sure that sufficient pressure is available in the system. For the crew you want at least 1200 psi, and for the passengers you want at least 1500 psi. So with that done, let's go ahead and apply air conditioning to the airplane. You gotta make sure that the APU had at least 1 minute to run on electrical power before air conditioning is applied. Now normally APU air is used for air conditioning only if the APU is supplying electrical power. So since our APU has been running for a minute, we move up and turn on all bleed air switches, both engine and APU bleeds. Note that the engine 2 and APU bleed switches are the 2 that you have located down here. And when those are on, we can quickly check that our cabin pressurization computer is set correctly. So we got to make sure that the cabin altitude selector is at least 500 feet above ground level for pneumatic pressurization system. So that's cabin altitude, has to be at least 500 above our airfield level, and we make sure that the ground flight switch is in the ground position. Next up, we move to the top of the panel over here, and we are going to open the cooling doors completely. You can see by default they're in the middle position. We're going to hold the switches up so that both cooling doors can move to the full open position. Like this, and the other one as well. Like this. Now with that done, we can turn on the packs, and when you are going to turn on the packs, turn them on one at a time and monitor the ampere meter on the engineer's auxiliary panel for an increase in electrical load to confirm pack fan operation. Unfortunately, this is currently not modeled in the aircraft, so we can turn them on both one by one over here. And with this, air conditioning is applied and the aircraft is basically prepared for initial operations. So like this, it's in a shape where you've got a nicely cooled or warmed, depending on the season, cabin. We've got electrical power applied to the plane, and we made sure that enough operating fluids, let's call it that way, hydraulic fluid, oxygen, oil, etc., are on board the aircraft. So from here on, we now go into our aircraft system checks, and we start them on the aft part of the flight deck by going up to the fuel dump panel that we can open, make sure that all the valves are closed, and we're going to test each of the light bulbs by clicking on the actual light switches. Now this is actually Boeing logic, the 737 has this one as well. Whenever you click on a light, the bulb is going to be tested. Okay, so all the valves are closed and all the lights operative. We can close the panel again. Move down to the flight recorder. Unfortunately, this is currently not modeled. Over here you would enter your flight number and the date. Then we go down to the engine fire detector, make sure that all the loops are on the A and B position. And with that done, we can move to the front part of the cockpit and hit the fire test switch. Make sure that the 3 engine fire warning lights illuminate, the bell sounds, and finally the 3 detector fault lights also illuminate. Last but not least, we go back forward to the panel again and hit the bell cutout switch in order to make sure that we are able to silence the alarm should it come up at any point. When that is done, put the fire test switch back into the off position, and that's it. Moving back forward again, we can test our door lights. All of the bulbs are working. Then we go down again, make sure that the autopilot switch is in the normal position, and go further down to the leading edge flap panel, put that one onto the light test position, make sure all the bulbs are working, and thereafter back to off. And finally we test the bulbs of the electrical warning panel down here as well. All of them work, switch can go off again. Last but not least, on the bottom we have the air conditioning flow selector, and we can just keep this one fully opened on 10, which provides maximum airflow to the aircraft. Now, if you were flying, for example, the passenger version, and you only had few passengers available, you could move this to a lower position, but for our purposes we're going to keep it in the full up position. From here we move forward to the captain's seat. So let's take a seat on the captain's seat right now, and we are going to carry out the captain's tests as well. We start on the light test that you can find down here, put the switch to the light test position. You will hear the autopilot disconnect warning sound, and then we go over all the bulbs in the flight deck and make sure that they all actually illuminate and that all the bulbs are working. When that is done, you can put the switch back into the neutral position and then into the dim position and ensure that all your lights illuminate in a dim position. And thereafter we can put it back to bright, and that concludes our light test. From here on we are now deviating from the official Flight Sim Studios manual because of a different flight deck layout, and we're going to start our normal panel scan flow as you would do it on pretty much any other airliner. So we start at the top, make sure that all the flight control switches are guarded, we'll move down, the flight control warning test can stay in the middle position. We don't need to do an anti-skid test in here, but we need to ensure the anti-skid is off. So ensure that the switch is not guarded and in the off position. The anti-skid system is only used for the takeoff in the 727, not for anything else. So this needs to be off. Moving back to the top then, we got our stall warning test, which we can conduct by placing the switch into the lower position. And you can see that both stick shakers are functioning down here. Put that off again. Then we have the flight recorder test. Hold the switch, observe the light and the warning sign. The compass has to be slaved. The instrument comparator test can be carried out now. So the instrument comparator are those switches that you can see up here. And they basically compare the left instruments to the right instruments, and when there is any mismatch, for example a different airspeed readout, then you would get a warning up here. So let's go ahead and hit that switch, and we observe that the instrument comparator lights do illuminate. Release the switch again, and off we go. Next up we got our instrument select switches, and we keep them on the normal position. So we have the nav radios, number 1 on the captain's side, number 2 on the first officer's side, and the remote compass is also number 1 on the captain's side, number 2 on the first officer's side. So both are in the normal position. Same for the vertical gyro, we keep that in normal as well. Then we have our cargo fire system, which we can test up here. You can see the arm lights illuminate and the fire warning sounds. Auto brake can be placed into the RTO position to arm the auto brake for reject the takeoff. Next up we continue in the middle over here. The wipers are parked and we can go ahead and arm the emergency exit lights. Moving back to the next panel, we have our engine start panel where all switches are guarded. The alternate flap switch is guarded. The compass is slaved on the first officer's side here as well. The cockpit voice recorder is going to be tested. Observe the needle go up and then release the switch again, needle goes back down. Then we have our passenger signs, which we can both turn on. And the passenger address system is the leftover from the passenger version of the aircraft. In the freighter we don't need to do anything with it. Then we go down to our transponder panel where we make sure that the transponder mode is off. And the standard squawk should be 2000, which we can dial in over here. System A when the captain is pilot flying, System B when the first officer is pilot flying. Moving on to the fifth column then, we have our window heat system, which we are going to switch on. And then we are going to do the overheat test, so move them to the up position and ensure that the overheat lights all illuminate, and thereafter we put the switch back into the neutral position. We don't need to do anything on the anti-ice monitoring here, but going down to the actual anti-ice control panels, we're going to select the monitor switch into the left position, ensure that the lights illuminate, and now we're going to turn the engine anti-ice on, and you can see that the lights go out as the valves are driving, and then they go back on again as the valves are in position. We also check the cowl and the right system, and we can check the same for the wings up here, and then we're going to turn the system back off and switch the engine anti-ice back off as well. Last but not least, we have our ProArt system down here, which is going to remain in the off position. And going down to all the lights that we have down here, basically set them to your liking so that you can properly see something in the flight deck. Personally, I prefer to have them somewhat on so that my instruments are readable well. Like this, and that's it. Going down to the exterior lights, we gotta turn on the navigation light as our aircraft is powered, and during the night we also turn on the logo light. Since it's daylight today, we do not need it. The rest of the switches is going to remain off at this time. From here we move down, and we have our flight director panel up here. Now, basically the flight director in this airplane is not coupled to the autopilot. For this reason, we are not going to use the flight director very much over here, so we can basically keep it switched off. The bottle transfer switch over here is on the left hand side, and then we can move down to our main panel. So first of all, we can click the autopilot disengage light so that it stops flashing. Then moving over our main panel up here, we observe that all the instruments are showing something expected. So for example, 0 speed, the clock is working correctly, the RMI is set to whatever we will need for the departure. We will talk about that in the next episode over here. Then we have our ADI, which we can test up here, make sure the warning flags all show, and the instrument deflects 20 degrees to the, well, technically speaking right, but the indicator 22 on the left over here, and 10 degrees of pitch. Release that one again. Set the appropriate QNH on your altimeter, and since we don't have any ACAS or anything up here to actually request our QNH, there's two ways how you can do this. Either you set them so that the airfield elevation shows, but that is the not so nice way to do this. Otherwise, you just got to Google for a META. For example, today the QNH is 1001, so we use the left knob over here to set the scale here to 1001. And then we use the right-hand knob to set the marker to our field elevation. The radio altimeter can be tested, you don't have to. That's normally maintenance stuff, but the green light illuminates and it does indicate 40 feet, so it works. Going down to our standby attitude indicator, we gotta press the knob on the lower right in order to align the device, like this. And then we can set our standby altimeter as well to the same numbers as our primary one, so 1001 is QNH, and the airfield marker to the field elevation. Moving on to the right, the nav GPS switch is in the nav position. Now, this one is probably going to be removed with a future update from aircraft fitted with an INS, so don't worry about this one. If you are flying an aircraft equipped with a GPS, set it as appropriate for your departure. Going down to the altitude select panel, if the switch is in the top position, you can change your altitude in steps of thousands. If it is on the bottom position, you can change it in steps of hundreds. Therefore, set it as applicable, but we are going to continue to deal with this one in our departure preparation video. Next up, we move down to the engine indicators. Check that the EPR basically shows nothing, and that all the other indicators show something expected. If they show something unexpected, it's an indication of a mechanical malfunction. Maintenance need to be applied. Moving on to the right hand side, then we have the first officer's side, and over here we can do the same tests as we could do on the captain's side and set the altimeter as well, just like this. Finally, make sure that the hydraulic brake pressure is showing 3000 psi, the pneumatic brake pressure as well. And then we can move down to the lower panel over here, and on this one we make sure that the Mach and airspeed warning set to number 1, the airspeed warning set to system A, the windshield and foot air can both be pushed in. Unless the window is fogging up, then you can turn on the windshield air and the foot air if your feet get cold in order to heat up the compartment down there. The yaw damper needs to be on the left side so that the system is in not in test mode. Then we move over to the right side to the ground proximity warning system. Normally, you could do the system test down here. As you can see, the GPWS warnings do work over here. So we heard glide slope and we heard pull up. And that completes our main panel. Moving down then, we have our control stand. I'm intentionally skipping over the INS here. That will be dealt with in the navigation part of the tutorials. Moving down to the main panel, our stabilizer trim is set to 0 degrees up here. Parking brake is set. Fuel cutoff switches on cutoff. And moving over to the right hand side, the stabilizer trim switch, neutral, the step trim light, tested, works. And finally, the stabilizer trim switches are both in the up, so in the normal position. Moving down onto the pedestal, we have our autopilot panel, and we basically start with the pitch selector in the vertical speed position, the turn knob showing wings level, the autopilot of course is disengaged, and the nav selector, in the ideal case, is initially kept on the turn knob position over here, so that your autopilot is not going to go crazy when you engage it later on. Moving down to our radios then, these radios are a little bit different to the normal radios that you're used to from other aircraft. Basically, you have two sides and you can switch between which one is active. So, on most modern aircraft, the left side is always the active side, and the transfer switch would transfer the frequencies from right to left. Not so in the 727. In the 727, you got the light on the top indicating which one is the active frequency. So let's say that you wanted to tune something, for example 122.8, then you would tune it on either side. You can tune it in the active, however that is not recommended, or you can tune it on the non-active side, and then when you want to use it, you simply flick the switch over, and you can see now the light tells us that the right frequency is the active frequency. And like that you can set both radios as needed. I do recommend Honeycomb or CTAF if you're flying in the USA, active on number 1, and then the guard frequency active in number 2, and the ATIS frequencies standby on number 2. We will ignore the nav setup down here for the moment, as that will be dealt with in our navigation setup tutorial, but we make sure that the switches here in the middle are all in the norm position. Finally, we go down to our trims, and we make sure that both the aileron and the rudder trim are in the neutral position. Last but not least, we finished the forward part of the flight deck, except for our audio control panel, which we find down here. So the middle switch determines which one we transmit on, and normally we want to transmit on VHF1. The volume knob controls the volume, and then the ones up here control that we actually listen to the system. So we want to listen to VHF1, VHF2, and also to the interphone system. And all the other switches can be kept off. Now this finishes our pre-flight checks at the pilot station. From here we move back to the flight engineer station, and now we're going to do the pre-flight checks on the flight engineers panel. Again, all of those can be done automatically using the mobile phone that you find on the left side of the flight deck. Now, the scan flow on this one is a little bit weird, and it will be different depending on any airline that you look at. Now, most airlines seem to use a scan flow like this. You start in the middle, and then you go up in a reverse spiral. So you go up here, left, down to the bottom, right, and then all the way up until you end up at the top over here. A little bit strange, but airlines. Okay, so we start over here with the wing anti-ice auto trip off. Put that into the ground test, ensure the light illuminates, and then you can put the switch to reset and then back to the normal position. Going down to the overheat on the right hand side, where we are going to test the overheat detection system. This one basically detects if there is any leak in the system. Moving up to the start valve open light, we push all of those switches to ensure that the bulbs are working. The aft cabin zone temperature basically can be kept as normal, and we push the overheat light to ensure that it is operative. The pack trip is kept in the cutout position, oxygen system off, and the light is tested and operative. Moving on to the left side then, we can keep our DC meter on the battery, or you can switch it to any of the transformer rectifier units as you wish. Moving down, we have the IDG disconnect switches in the guarded position, and the switches in the in position. Moving further down, Essential power is selected to the current power source, so the APU in this case. The generator drive oil temperature obviously is 0 because the engines are not running, and all the generator control switches are in the neutral position. Once again, we ensure that all of the lights are working, and by pressing all of these buttons. Moving further down, the frequency selectors are in the 12 o'clock position, and finally the AC meter is set to the current active power source, in our case the APU. Moving further down then we get to our fuel controls. Over here we turn on only one pump per tank. So we're going to switch on one pump over here per tank and ensure that the pumps operate by observing the lights go out. Check the fuel quantity to be sufficient for our flight. So in this case over here we got 7,000 pounds per fuel tank, so 21,000 pounds of fuel in total. We do the fuel quantity indicator tests by pressing and holding the test button, observe the quantity go down to 0 and then go back up. And we do that on all 3 of the fuel quantity indicator gauges that we have available over here. So going further down we have our fuel crossfeed valves, and we close the valves of the 2 wing tanks, and we only keep the valve of the center tank open. Observe the lights illuminate and then go dark. They illuminate while the valve is in transit and then go dark when the valve is in the commanded position. However, the light bulb is connected to the same circuit breaker as the actual valve. For that reason, after they turned off, we've got to press to test the light to ensure that indeed the system has operated correctly and that the circuit breaker didn't pop while it was in operation, which would look the same as a transited valve. So we are going to test the lights over here, and finally we're going to turn the fuel switches on for all 3 engines over here. Again, observe the lights go bright then out, which indicates correct operation of the valves. The hydraulic brake interconnect switch is tested and the valve is going to stay guarded, which is the closed position at the moment. Going down then to the fuel heat panel, we are going to test that all the valves are operative and the heating system itself is turned off. Unless the fuel is in negative temperature range, then you can turn them on to heat up your fuel. Moving on to the hydraulic system, we ensure that the 2 engine pump lights are illuminated and turn on the 2 engine pumps themselves. Test the overheat light, make sure the ground interconnect is closed and the fluid shutter valves are in the guarded position. Moving on to the hydraulic B system, we test that the second hydraulic pump is operating correctly, and then we can switch it off again. We only need a single hydraulic pump on the ground. Again, test all the lights to ensure that they are working. And then we can move further to the right. The oil cooler is in the ground position. Service interphone off. Now, the service interphone is especially interesting if you're flying the passenger version of the aircraft and if the ground engineers want to plug in at any position other than the normal position in the forward wheel well. So we can keep it off in the freighter. Moving further up, we have the engine vibration meters test. Hold the test switch, ensure that the gauges are coming up, and once the gauges are within the required range, 3.5 to 4.5, we can release the switches again and observe the needles going back to 0. Finally, the engine vibration system is set to the lower 2 switch positions, and that moves us up to our air conditioning panel. Now, many of you are going to recognize this panel, as it is quite similar to the one in the 737NG. So basically what we do is we're going to select our target flight altitude, so that's the planned cruising level. In our case 330, and we can see that this happens to be coincidentally the default selection, otherwise you could change the flight alt down here with that selector. We also have the landing altitude selector, which we can set to our destination airfield elevation. Now, the destination field elevation is either available in your flight plan, depending on the flight plan layout that you use, or you can get it from your destination airfield charts. Now, both are acceptable means of obtaining that data. In my case, I got it from my flight plan. It's 175 feet, so we are going to select the next closest value, 180 over here. Moving up then, the standby system The cabin rate is roundabout in the 11 o'clock position, and the standby cabin altitude target can be set according to the scale on the left side here. So we plan to cruise in 33,000 feet, so the cruising altitude is down here, the cabin altitude is up here, and the differential pressure is at the very top. So 33,000 is just over here, so the cabin altitude corresponding to that would be 4,800 feet. So we can go ahead and select 4,800 over here as a reference. Now the manual outflow valve control switch is in the closed position, the mode selector is in ground, and finally we could do a system check over here, but currently there's no sense demonstrating that because the system is currently bugged in the Flight Sim Studio 727, so I can't demonstrate it at the moment. I'm sorry for that. Last but not least, we check that all the lights are operating over here by clicking on the switches, and that illuminates the lights. Going further up then, our cabin altitude selector shows 0 differential pressure, and the actual cabin altitude equals the airfield elevation. The rate of climb should be 0. The temperature either shows the cabin temperature or the outside air temperature, and the temperature selector is set to whichever part of the cabin you want to see. Moving up then to our control panel, all the bleeds are open, so engine 1 bleed, engine 2 bleed, APU bleed, and engine 3 bleed. The packs are turned on, the cooling doors are in the full open position, the cargo heat outflow is set to normal, and the gas door fan is set to on. And that concludes our flight deck checks for the Boeing 727. From here on, we go into working with our navigation systems and working on our standard instrument departure setup, but I will leave all of those to a dedicated video so that it is easier to find. For this reason, thank you very much for watching. I do hope that you have enjoyed this one. I do hope that you have learned something. Leave your feedback in the comments below, and as always, if you're up for more, don't forget to like, comment and subscribe. And if you really love what I'm doing in this channel, I would appreciate a small donation through the Buy Me Coffee link in the video description below. Thank you very much for watching, and I'm looking forward to see you all again on the next one.